Now here is a question. Y is equal to this function, and capital letter M is the maximum value of y, and small m is equal to the minimum value of y. We are finding the ratio between the maximum and the minimum value of y. Now here I would like to present three methods. Now method one. Method one is that since this y is equal to the sum of two square roots, therefore y must be non-negative. Y cannot be negative, right? Positive or zero, positive or zero. So y is positive or zero. Then y maximum will yield y square maximum, right? And y minimum will yield y square minimum. Okay. So y square is equal to 1 minus x, this square plus this square, x minus 3, plus twice the square root, 1 minus x and 1 plus x. So okay, instead of finding the maximum value for y square, y, we are finding maximum value for y square, because they are, as explained, y is a non-negative. Okay, so y square is equal to 4 plus 4 plus 2 square root 3 minus 2x minus x square. So for y square maximum, is the inside must be maximum, right? Inside the inside square root is a curve like this, because x is from 1 to minus 3, right? So this is open downward, so this is something like this. This is the domain of y. So maximum value must be there, it's a -1 in the middle. So the y square maximum is equal to y square value, x equal to -1. So this is -1, right? -1, there's a 2 plus 2, so this is 4 plus 4 equal to 8. Right, x equal to -1, yeah, that's 4. Now, therefore, y maximum is equal to square root 8, which is equal to root 2. And similarly to that, y square minimum, obviously, y square minimum when this is 0. Right? When x equal to 1 is 0, when x equal to -3 is 0. So y square minimum is 4. It's 4, then this is 0. Therefore, y minimum is equal to 2. Y cannot be negative, right? Therefore, m over m is equal to 2 over 2 equals to root 2. See, that's the method of 1. Method of 2. Method of 2, I'm using the derivative. dy dx is equal to, this is square root, this is 2 square root 1 minus x negative 1 plus square root 2x minus plus 3 1, right? That is first derivative. Let this be 0. We're looking for the maximum or minimum, right? So this means 1 minus is equal to 1 plus x, right? So x equal to negative 1. Yeah, so at x equal to negative 1, y may be maximum, maybe minimum. So we are taking the derivative, second derivative test. The second derivative is the derivative of that, right? Is negative 1 minus x is negative half plus half 1 plus 3 negative half derivative. Okay, that derivative is second derivative. So this derivative will be 1/4 times minus negative times negative 1 minus 1/4 x plus 3 negative 3/4. Yeah, when x equals, we test next negative 1, right? So this is positive. So the whole thing is a negative. This is a positive, this is negative. Therefore, second derivative with respect to x is negative, which means that x equal to negative 1 gives the value of y maximum. Okay, therefore y maximum is equal to y when x equal to negative 1. Right? Yeah. So y equal to square root 2 plus square root of 4. Right? So this is equal to 2 root 2. Yeah, so we find the maximum. Now, because we have only one critical point, so the minimum value must happen at the end point. We have only one critical point which creates maximum value. So the minimum value is at the end point. Now the end point is, for this function, the end point is cannot be more than 1, right? Cannot be more than 1. Cannot be less than negative 3. So that is the domain. So these are two endpoints. Check the endpoints. Endpoints. So y x equal to minus 3. Minus 3, this is 0. Minus 2, this is 2. And y x at 1 is root 2. At 1, this is 2. So minimum value, minimum value is 2. Okay, so m divided by n is 2 root 2 divided by 2 is root 2. So we get the ratio. Now that's method 2. Method 3. Method 3, I'm using vectors. Let A is a vector 1, 1. Let vector B is root 1 minus x and root x plus 3. And obviously the y is equal to, let me write this way, y is equal to vector A the dot vector B, which is equal to this time this plus this time this, right? So this is so that is exactly the function given. So y equal to A dot B. But you know what is the maximum for dot product is equal to the A dot B maximum, right? Maximum, which is equal to the magnitude of A times the magnitude of B, or norm of A times norm of B. Isn't it? So norm of A is equal to square root 1 plus 1. Norm of B is this, right? Square root. This is square is 1 minus x plus that one. X plus 3 is 4, right? So this is equal to 2 root 2. You know, we find the maximum. For minimum value, well, it should be, well, let me put it this way. Okay, A dot B, this is y. The definition of A dot B is norm of A times norm of B times cosine theta, right? Now the maximum value when cosine is 1. Minimum value, cosine should be -1. That's minimum value. But here, we know that these two, now let me put this way. These two vectors, A is here. This is a 1, this is a 1. That is A. Now B, vector B is this square plus this square, which is 4. Square root is 2. Therefore, the magnitude of B is 2. See? The magnitude of B because the square root must be positive. Square root must be positive. The component of B in the first quadrant. Therefore, B is a vector like that, you know, in the first quadrant. If B is vector in the first quadrant, A is here. Therefore, the maximum angle between A and B, theta maximum, is equal to quarter pi, because the angle between A and B, it cannot be greater than quarter pi, which is the minimum value of cosine theta, because a large angle, smaller value of cosine. Therefore, the minimum value of A dot B is a dot product of AB at the angle is quarter pi. because the vector here or vector there, it makes the dot product is the minimum, right? Therefore, y minimum is a dot b, at the value quarter pi, which means a b norm times cosine quarter pi, which is equal to, this is square root 2, this is square root of 4, this is 1 over square root 2, right? So this becomes 2. In other words, y minimum is 2. Therefore, m over m is 2 root 2 over 2 is root 2. See, that is the answer getting from the method by using the vectors. Well, I hope that explains. Thank you.